Unit 2, Number Algebra Geometry, non-calculator paper. Question 1. Here are some patterns made from white centimetre squares and grey centimetre squares. So we've got pattern 1, 2 and 3. A pattern has 20 grey squares. Work out how many white squares there are in this pattern. Well, there's a grey pattern, a grey square either side on the pattern, so we'll start with 20 divided by 2 gives me 10, and then we've got an extra white one on the end of each pattern, so 10 add 1 will give you 11. Find an expression in terms of n for the total number of centimetre squares in pattern n. So if you imagine in the first pattern we've got 1, 2, 3, 4 centimetres squared. In the second pattern, so when n is 2, we've got 1, 2, 3, 4, 5, 6, 7 centimetres squared. Pattern 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in pattern 3, 10 centimetres squared. And then if we look, the difference between these, we're adding 3 each time. So we know it's going to be 3n, and then it's going to be 3n add 1. 3n would be 3, 6, 9, whereas we've got 4, 7, 10. Question 2a. Simplify 5 to the power 4 times 5 to the power 6. Well, we're multiplying, we're going to add the powers, so that will just be 5 to the power 10. And here, simplify 7 to the power 5 divided by 7 to the power 2. So when dividing, we're taking away the powers. So 7 to the power of 5 divided by 7 to the power 2 is going to be 7 to the power 3. Both 1 mark each there. Mark scheme for question 1. So part A is worth 2 marks. You get a method mark for realising you're going to need half the number of white squares as grey squares. And then you get an answer mark for 11 and realising you had to add that one on. Part B, or part B, you've got 2 marks here, so you get a mark for the 3n and also for realising that it is plus 1. So they treat each bit separately there. 2a, 1 mark, you just have to have 5 to the power 10. And part B, 7 to the power 3. Question 3. T equals x squared minus 5y. X equals 6 and y equals 4. Work out the value of t. So t equals whatever my x is squared, so 6 squared, minus 5 times whatever y is, and y is 4. So that will be 36 minus 20, which means t will be equal to 16. Question 4. It says find the size of the angle marked x. So we're looking for this angle over here. Now if we look across this way, or you might be able to spot straight away, this angle here and this angle here are going to be the same. So we're going to say that x is 126 degrees. And the reason for this is that alternate angles, which they both are, alternate angles are equal. So when it says give a reason, we're going to say alternate angles are equal. Question 3, mark scheme. So it's out of 2 marks. The first mark is for correctly substituting in your values for x and y, so 1 method mark, and your second mark for correctly identifying t as 16. Mark scheme for question 4, you get 1 mark for correctly identifying x as 126, and then that second mark for relating to geometrical property in parallel lines, so stating alternate angles are equal. That is your second mark. Question 5. Here is a list of ingredients for making cherry scones, and our list makes 8 cherry scones: flour, margarine, sugar, cherries and milk. Chen wants to make 20 cherry scones. Work out how much milk he will need. So first of all, we've got to look. Our recipe makes 8 scones and Chen wants to make 20 scones. So we need to work out what we've times 8 by to get to 20, and we can do the same to our milk. So in order to do that, I'm going to do 20 divided by 8. So how many times 8 go into 20? 2.5. So if we look, 8 times 2.5 would give us a 20 scones. So they want to know how much milk we'd need. So we're going to take the milk for 8 people. We're going to times it by 2.5, and that will give us enough milk for 20 scones. The way I would do that, 160 times by 2 and 160 times by 2.5. 160 times 2 is 320. 160 times 0.5, sorry. So then I've broken it down, 2 and the 0.5. Now anything times by 0.5 is the same as dividing by 2. So 160 times 0.5 is 80. And then when added together, 320, add 80, we get 400, which means Chen must need 400 millilitres of milk for 20 scones. Part B. Sophie has 80 grams of sugar and 300 grams of flour. She has plenty of the other ingredients. What is the greatest number of cherry scones she can make? You must show all your workings. So Sophie has 80 grams of sugar and 300 grams of flour. So if we look back up at the top, for 8 cherry scones it was 40 grams of sugar. So for 8 scones it was 40 grams of sugar. And if we've got 80, well 40 times 2 is 80, so we'll do the same here. You must be able to get 16 scones from that 80 grams of sugar. So for flour, we needed 200 grams of flour for 8 scones. So 8 scones, you need 200 grams of flour. Now this side's a bit tricky. Sophie's got 300 grams of flour and she wants to know how many scones that's going to cook for. So what if we times 200 by to get to 300? We times that by 1.5. So let's do the same to this side. Times 1.5. 8 times 1.5 gives you 12. So the question says, what is the greatest number of cherry scones she can make? Well, with the sugar it's 16, with the flour it's 12. So overall she can only make 12 scones as she's limited due to her 300 grams of flour. Mark scheme for question 5. So part A is worth 2 marks. Your first mark is your method for working out the scale factor, or the 2.5, and the second mark is for using that and getting your answer of 400. Part B is worth 3 marks. So your first mark is for your method for finding the limited ingredients, so what we've done here. So showing your method of how you got to 12 scones and 16 scones. You also get another mark for this, for reaching a conclusion based on these calculations. So for down here we've looked at 12 scones and 16 scones and realising that it's 12 scones. Your final mark is stating your answer of what Chloe is limited to. Question 6. Here is a box in the shape of a cuboid. So we've got 4 centimetres, 2 centimetres, 6 centimetres. Complete an accurate drawing of the cuboid on the isometric grid. One edge of the cuboid has been drawn for you. So they've already drawn, if we measure this one, so they've already drawn that 4 centimetre line. So we know going up from that is going to be the 2 centimetres. So 2 centimetres, 2 centimetres, and we can then connect that. So we've just measured 2 centimetres and we know the other one's the same. And then the final measurement, 6 centimetres. So we're going from the bottom of here, 6 centimetres, and we're going to label that 6 centimetres. And then from this point, so if this is 6 centimetres, this is going to be 6 centimetres, and so is that one. So one more edge along here, and then join those two. Your final one over here to make the cuboid, 6 centimetres, which means we'll join these two to complete. Now to double check, that should go to 4 centimetres and these should be 2 centimetres. Oh, mine hasn't quite. So my pen's a bit too thick, but 2 centimetres, 4 centimetres, and going back 6 centimetres, as long as you've done those accurately. So you get 2 working marks for this. The mark scheme for 6A is 2 marks, and it just says a correctly drawn or an accurately drawn cuboid. So they would measure your sides and you'd get your 2 marks. Question 6B. The box is made to hold cubes. Each cube has edges of length 2 centimetres. Work out the largest number of cubes that can fit into the box. So if we take our measurements from our bigger box of 2, 4 and 6, we've got volume of the big box was 2 times 4 times 6. So 2 times 4 is 8, times 6 is 48 centimetres cubed. If we work out the volumes of our small cubes, they've called them, that's going to be 2 times 2 times 2. 2 times by 2 times by 2. So the volume of one of these smaller ones is 8 centimetres cubed. So to work out how many of these smaller ones fit into the larger one, we will do 48 divided by 8, which gives us 6. So our answer, 6 boxes. Because that's how many of the smaller ones, that are volume 8 centimetre cubes, will fit into the larger volume of 48 centimetre cubed. So the mark scheme for this one is out of 2 marks. So mark scheme for question 6B. Your first mark is a method mark for these 2 bits here. So you only get 1 mark for working out the volume of the big box and the volume of the smaller one. And then your second mark is an answer mark for stating 6 or 6 boxes. Question 7A. Simplify 2e, add 3f, minus e, add 4f. And that's worth 2 marks. So first of all, let's collect all our e's. So we've got 2e minus e, so that's just going to give you 1e. And then we've got 3f, add 4f. So we've got 3f's plus the 4f's over here, gives us 7f. So altogether, e plus 7f. Part B. Expand 5 and then brackets 2c, add 3d. So we're going to be multiplying whatever's on the outside and timesing it by what's on the inside. So you're going to do 5 times 2c, which will be 10c, and you can do 5 times 3d. So 5 times 3 is 15, and don't forget the d. 10c, add 15d. Part C then. Here are 2 straight lines, A, B, C, D, E and P, Q. So this is our first line and our second one. In the diagrams, all the lengths are in centimetres, and it says that AE, so that top one, is 2 of PQ. Find an expression in terms of x for the length of DE. Give your answer in its simplest form. So they've told us AE equals 2 PQ. So we can start substituting in what we know. We know that A to D, so that's x plus x add 3. So we've got x add 3, add 2x. And then we've got the bit here we don't know, DE. So all I've done, substitute what I know for A to E. So A to E is this, add DE, and then 2 PQ. Well, PQ is 3x minus 2. So it'll be 2, 3x minus 2. So we knew P to Q was that, and it's A to E is 2 of them. So we've made it 2 of them because we want to work out what D to E is. So let's collect these up. We've got 4x's all together. 1, 2, 3, 4. Add 3, add DE. So again, this side of the equation has just been A to E, which they've already told up here. And then this side was the 2 PQ, so 2 of them, because they told us that they were equal in the question. So we multiply that out. 2 times 3x is 6x, and 2 times minus 2 is minus 4. Now we want to work out what DE is, so we want to get DE on its own on one side. So I'm going to minus 4x from this side, and I'm going to take 4x from this side. So that will leave me with 3 add DE equals 2x minus 4. And we're going to take this 3 over. So that will leave me with DE equals, so if I'm at minus 4 and I take away another 3, I'm going to be at minus 7. So 2x minus 7. So our answer, DE equals 2x minus 7. So the hardest bit of that was probably at the start, substituting everything in. So they told us AE equals 2PQ, so AE equals 2 of them, and that was the first step that we did. Rearrange to get DE equals 2x minus 7. So the mark scheme for question 7. 7a was worth 2 marks, so you get a working mark for the 2e minus the e. I'm correctly getting that as e, and you get your second mark for 3f, add 4f equals 7f. So that's where those 2 marks come from. Part B is only worth 1 mark. There's no negatives here, so it should be straightforward. So that is just 1 answer mark there. 10C, add 15D. Or it's a working mark or an answer mark. So down here, question C is worth 4 marks. So your first mark, is for correctly substituting in AE and 2PQ. So that's your first mark for correctly substituting. Once you've got that, your second method mark is for correctly expanding this side and collecting up all your like terms this side. So that would be your second method mark. Third method mark is for correctly rearranging to get DE equals. So that's taking the 4x or the minus 3. So that is your third method mark. And the fourth mark is an answer mark. So for getting DE equals 2x minus 7. Question 8. Work out an estimate value of 89.3 times 0.51 divided by 4.8. Now, if a question ever asks you to estimate, you're going to round everything to one significant figure. So, if we've got 89.3 to one significant figure, will give me 90. 0.51 to one significant figure, now the leading 0 doesn't count, so that'll be 0.5. 4.8 to one significant figure is 5. So to work this out, 90 times 0.5, so if we're timesing by 0.5, it's the same as dividing by 2. So that'll be 45, and we're dividing it by 5. So your answer would be 9. Question 9. Write 152 million in standard form. So I'd write this out in full to help me. 152 million in standard form. So I'm going to look where am I going to put the decimal point, so this number is going to be between 1 and 10. So it's going to give me 1.52 times 10 to the something. Now if you got as far as that, that would give you 1 mark, but you need to get the full standard form. So you need to think, what if I times 1.52 by to get to 152 million as a power of 10? So then your final mark will be stating 1.52 times 10 to the power 8. So it helps to write out the number in full, and then we can see how we've gone from this to this. 9b, write 2.4 times 10 to the minus 3. Now I'm going to 10 to the minus 3, 0.010. So it's going to be 2.4 times 0.010. Now the way I would do that, I've got 1, 2, 3, 4 numbers after the decimal point. Now I know 2 and 4 are going to be in there, so I'm going to work backwards like that. So again, it's 2.4 times 0.010, so it's going to get smaller. We know the numbers 2 and 4 are going to be there, and I've got 1, 2, 3, 4 numbers after my decimal points in total. So 1, 2, 3, 4 numbers after my decimal point in total. Mark scheme for question 8. So it's 2 marks. The first mark is a method mark for correctly rounding to one significant figure. Now it states that at least 2 of these have to be correct. So for example, if you put 80 instead of 90 or 0.4 instead of 0.5, you could still get that method mark. You need at least 2 of those correct. And then that second mark is for getting your answer as 9. Mark scheme for 9a. So it's 2 marks. So like I was saying, if you got as far as this, you'd get 1 mark. And then you need to have the full standard form. So a number between 1 and 10 and to the power of, or times 10 to the power of something, that gets you that second mark. So this is almost your method mark, so you're working it out, and then your final answer mark, 1.52 times 10 to the power 8. This one was only worth 1 mark, 9b, so it's 1 working mark, 0.0024. Question 10. A, B, C and D are 4 vertices of a regular 10-sided polygon. Angle BCX is 90 degrees. Work out the size of the angle DCX, DCX. So they want this angle here. So in order to do that, I'm first going to work out this middle angle here, or the interior angle, so this one, which is angle BCD. So I'm first going to work out angle BCD. In order to do that, it's an interior angle. So the formula for an interior angle would be 180 times number of sides minus 2 divided by the number of sides. Now the question tells us this is a 10-sided polygon, so that would be 180 times 10 minus 2 divided by 10. So 180 times 8 divided by 10. Now it's no calculator, you might just use a lattice method for the top bit and then divide by 10. Either way, you will get to your answer of 144. So we've just worked out that interior angle as 144 degrees. Now this whole angle, or angles around a point, add to 360. We've already got this 144 and we've got this 90. So to work out that angle that they're asking us for, we'll do 360 minus them. So that would be 360 minus the angle we just worked out, minus the 90 degrees angles they've just given us, which gives us an answer of 126 degrees. So angle DCX, which they've asked us for, must be 126 degrees. So that again, we've worked out the interior angle, 144, using this formula. And then we've done angles around a point, or 360, minus 144, minus the 90. And that's given us 126. So the mark scheme for question 10. This is worth 3 marks. So your first mark is for correctly using this formula, substituting that in. So method 1, so that's something you need to learn. The second mark is down here, method mark, for knowing angles around a point minus those two which we already know. So that'll be your second method mark. So interior angles, angles around a point, and then that final one is an answer mark for getting the correct answer of 126. Question 11. Here is the cross section of a steel girder. The cross section has 2 lines of symmetry. The girder is a prism. The length of the girder is 200 centimetres. So these are both important bits of information. Work out the volume of the girder. So first things first, the volume of any prism, so volume of prism is going to be area of cross section. So that's this, what we're seeing up here. And it's going to be times by the length. So volume of a prism, area of the cross section, so we're going to have to work out the area of this, times by the length. So this cross section I would split into 1 trapezium, 2 trapezium, 3, 4 trapeziums, and then the rectangle in the middle. So I'd work out the area of all of them, add them together, and then times by the length. They already tell us the length is 200, so we know this bit already. So area of cross section, we're going to split into 4 trapeziums, and 1 rectangle. So we know this is trapezium because it's got a pair of parallel lines. So let's take one of these and draw it out here to help us. So right angle, 3 centimetres and 4 centimetres. Now in your formula book at the front, it tells you the area of a trapezium is half A plus B times height. So that is in your formula booklet at the front. So we've got A and B as our 3 and 4. A half, 3, add 4, times by the height. Now the height is this straight edge along here. I'm not going to try and work out the slanted one. So the height is this straight edge along here. Now we can see the full length is 30 centimetres. And we can see that the length of the rectangle there is 2 centimetres. So if we want to work out our height, first of all it's going to be 30 minus 2, so we're going to have 28 centimetres. That's between this and this. So in order to just get one of them, we need to divide it by 2. So height would be 28 divided by 2, which equals 14. So we can plug this back in. So we already had a half, 3, add 4, and we now know the height is 14. So area equals a half times by 7 times by 14. So what I would do, we know that if you times something by half, it's the same as dividing by 2. So if we did a half times 14, same as saying 14 divided by 2. So area equals 7 times 7. See what we've done? Half times 14 gives me 7 times by 7. So the area of one of those is 49 centimetres squared. Now we've got 4 of them, because essentially we've just worked out this bit here, and we've got 4 of them. So I have to come over here. We're going to do 49 times by 4. So you might want to do 50 times 4, which is 200, and then minus the 4, or use lattice method. 49 times 4 196. So we're going to stop there. That is our areas of the 4 trapeziums. And we said we need to also, so we just worked out that this plus this plus this plus this has given us 196 centimetres squared. So now we need to work out the area of that one rectangle. So this bit here. So we can see from the side its length is 68, and then as we said earlier, it's 2 centimetres. So nice and easy. Area for the rectangle is going to be 68 times by 2, which is going to be 136 centimetres squared. So now I've got the area of our rectangle and the area of our trapezium, or our 4 trapeziums. We can add these together. So I'm going to have to come over here. So we've got area of the rectangle plus the area of our 4 trapeziums. So 6 at 6. So at the moment, we go back to volume of the prism. We've just worked out the area of the cross section. 4 trapeziums at the rectangle was 332. And we're going to times it by the length of 200. So if I come down to the bottom here, volume equals area of the cross section, which we just worked out, and we're timesing it by the length 200, which they gave us in the question. You could do lattice method, or you could do 332 times 100 and then times by 2. Either way, you should get your volume equal to 66,400 centimetre cubed. So remember to use your formula booklets for things like this, and then take each step as it comes to finally get your answers. Volume equals 66,400. So question 11, mark scheme. It was out of 5 marks in total. Your first mark is a method mark for finding the area of a trapezium. So we're starting area of trapezium, which we worked out. The second mark is a method mark for working out the area of the rectangle, so an easier mark. Third mark is for finding the total area, so that's for adding these two together. So remember, we had to do 49 times 4 and then add the 136. The fourth mark is for taking your total area and realising you have to times it by 200 to get the volume. And that fifth and final mark is for getting the answer correct, 66,400. 5 marks in total. Question 12a. Factorise fully 6ab add 10ac. So first thing, we can see that there's an a in both of those. So if we were to pull a out, a times what equals 6ab, so it'd be 6b, and then a times what equals 10ac, so it'd be 10c. And then if fully factorised, we can also see that 2 is a factor. So if we pull out 2, we would have 3b, because 2 times 3 makes 6, add 5c. So my answer is 2a in brackets, 3b, add 5c. Expand and simplify. So there's many methods. I'm going to use FOIL. First, outers, inners, last. So first times first would be x squared. Outer times outer, so that's plus 7 times x, which would be 7x. The inners, so that's minus 5 times x, minus 5x. Just zoom out a bit. Last times last, minus 5 times 7 will give me minus 35. So if I was to write all of those out, x squared plus 7x minus 5x minus 35. These can be collected together. So if you have 7 or something, you take away 5. I've just got 2 left. X squared add 2x minus 35. So my final answer. Give your answer to this in its simplest form. So we've got 2m squared t to the power 6 all over m to the power 4 t to the power 2. So I would split this up. So we've got m to the power 2 divided by m to the 4. Now we know in dividing with powers we take it away. So this would be almost like saying 2 take away 4. So it would be minus 2. That's with our powers because we take them away when dividing. So that would be m to the minus 2. And then with our t's, because we're doing it separately, t to the 6 over t to the 2. So if you have t to the 6 divided by t to the 2, you're taking it away. So it's almost like 6 take away 2, which will give you 4. So that would be t to the 4. Okay, and then we still had the 2 up at the front. So it would be 2 m to the minus 2 and t to the 4. So we've broken it down, kept the 2, broken to the m's, and broken with the t's. 12d, factorise y squared minus 16. So by looking at this, it's the difference between two squares. We know that because this is squared and this is a square number. So the square root of 16 is 4. So in your brackets, y and y will make the y squared, and then we know we're going to have a plus 4 and a minus 4. If you were to check and expand it out, you'd get y squared, add 4y, minus 4y, minus 16. So we know that one's correct. So both of these are square numbers. It's the difference between two squared. Last one, simplify h squared all to the power minus 3. So the rule with this one, we are going to times the powers together. So essentially we need to do 2 times by minus 3 to give me minus 6. So because we multiplied those powers together, we no longer need the brackets. So it'd be h to the minus 6. And that's it, fully simplified. This one and that one. So let's look at the mark scheme for question 12. 12a, you get 1 working mark for pulling one of the factors out, and then you get that second mark for fully factorising it. So you might have just pulled out 2 or just pulled out a, then if you pulled out both, you get both marks. Part B is worth 2 marks. Method mark for this bit, so you need to get at least 3 of those correct. And then an answer mark for fully simplifying x squared, add 2x, minus 35. Because the question does state to simplify. 12c, 2 marks, so it's 2 working marks. So essentially you get the 2 marks working with the powers here. So that's 2 working marks, and it should lead you to 2m to minus 2 t to the power 4. This one just had to spot difference between 2 squares. So that was just 1 working mark. You should have spotted that one. And then 12e, sorry, was just 1 working mark again. So you should have spotted that you'd have to do 2 times the minus 3 to give you minus 6. So it'd be h to the minus 6. Question 13. The perimeter of a square is root 120 centimetres. Work out the area of the square. Give your answer in its simplest form. So if this is the perimeter, so that's all 4 sides added together, one of those sides must be that divided by 4. So that's the length. Because all sides on the square are the same length. If that's the perimeter, that's all 4 of them, so one of them would divide that by 4. To work out the area of a square, you're going to do the length times the width, which with the square they're exactly the same. So it would be the length of one side times itself or times another side. So we're looking at root 120 over 4 squared. So if you've got a square root of 120 and you're squaring it, that's going to cancel out to 120, and then we need to do 4 squared to get 16. So at the moment we've got area equals 120 over 16. Now I want it in its simplest form. So I would divide both of those. If you can't spot it straight away, I'd divide both of those by 2. So we've got 60 over 8. Divide by 2 again. 30 over 4. We could divide by 2 again. 15 over 2, or 15 divided by 2. Which would give me 7.5. So all we've done is simplified from 120 over 16, and we've got 7.5. And that is our answer. Question 13, mark scheme. So that are 3 marks. Your first one is a working mark for realising the length of one side would be root 120 divided by 4. Your second mark is a working mark for getting 120 over 16 as your area. And the final one is an answer mark for getting 7.5. So they would have accepted 15 over 2, but they wouldn't have accepted this because it's not in its simplest form. So we had to either get 15 over 2 as a fraction or 7.5. Question 14. A and B are points on the circumference of a circle, centre 0. So A and B. Now straight away we can label those. They're both radii, so they're going to be equal length. AT is tangent to the circle. Angle TAB is 58 and angle BTA is 41. Calculate the size of the angle OBT. So they want that whole angle there. You must give reasons each stage of your working. So first of all, we're going to start with this angle here. So angle TAO equals 90 degrees. Okay, and we're going to state our reason because the angle between a tangent and radius is always equal to 90 degrees. So we're going to start there. So this angle is 90 degrees. That must mean that angle OAB, so this one here, angle OAB equals 90 minus 58 to 32 degrees. We know that because that whole angle is 90, we've got 58, so this one here must be 90 minus 58, so it's 32. Now that helps us because if angle OAB is 32, then angle OBA, so here, must be the same. Angle OBA is also equal to 32 degrees, and the reason for this, the angles at the base of an isosceles triangle are equal. So angles of isosceles triangle. So those two base angles, because we labelled that as an isosceles triangles, are the same. So we did 90 minus 58 to give us 32. So that one is 32. Now we want the whole of that blue angle that we shaded in. So to find ABT, so the other shaded bit there, this is within a triangle. So to find angle ABT, we can do 180 minus 58 minus 41, to give us 81, and that has just given us this angle here. So the rest of what we wanted to work out, 81 degrees, because they're all within that triangle. Now we want the whole of that, so we're going to do 81 add the 32 that we just found. So what they're asking for, which was angle OBT, equals 81 add 32, so both those angles, which equals 113 degrees. So the mark scheme for question 14. You get your first working mark for stating angle between a tangent and radius is 90 degrees. Your second is a method mark for spotting angles at the base of an isosceles triangle equal, or for working out 90 minus 58 and getting 32. Second method mark there. This question's out of 5 marks. Your next method mark would be for working out the angle ABT. It's working out this 81 degrees because of angles in a triangle. That would be your third. The fourth is a communication mark, so that is for stating all these reasons why as we've gone along. So here we should have said, or you could have said, angles in a triangle add to 180. Although the mark scheme states that you need this one, so you have to have this one and one of these. Ideally you want all of them to be safe, but you need this one at the top, and then explaining your steps as you go. And then the final one is an answer mark for getting 113 at the end. So again, there's a working mark, method, method, and then that clarification mark, which I didn't put on, is for stating this and then one of these at least. And then you get your answer mark at the end. Question 15. L is a straight line. The gradient of L is 4. L passes through the point 0, 2. Write down an equation of the straight line L. So we're going to want in the form of this. They tell us the gradient, so we know the gradient M is 4. And they give us 2 points on the line which we're going to substitute in. So when x is 0 and y is 2. So we've got 2 equals 4 times 0 plus c. So this will help us work out our plus c. 4 times 0 is 0, so 2 must be our c. So the full equation, y equals 4x, they told us the gradient, and then we've just worked out the plus c. That's my final answer. It says L1 is a straight line parallel to L, so we've just worked out L. L1 passes through the points with coordinates 2, minus 6. Find an equation for L1. So if it is parallel, it will have the same gradient. So if we were working out L1, it's going to have the same gradient as L, which was 4. So it's going to be 4x plus c. You're happier seeing it? We know we're working with L1. And then this one passes through the coordinates 2 and minus 6, which we're going to plug in. So when y equals 2, when x equals 2 and y equals minus 6. So we've taken our minus 6, put it as y, taken our 2 and put it as x. So now we've got minus 6 equals 4 times 2, which is 8. And we're going to add the c. So if we wanted to find out what c was, we'd minus 8 from both sides. So if you're at minus 6 and you take away another 8, you're going to be at minus 14, which will give us the value of c. So the equation for that line for L1 was 4x, because we knew the gradient was the same, and minus 14, because that's what we've just worked out our plus c as. So the answer, the mark scheme for 15A and B. 15A was 2 marks. Your first one was a working mark for realising the gradient was 4 and plugging that in. And the second one was for calculating C as 2. And that would leave you with y equals 4x at 2. 15 part B. So your first mark is for realising that if they're parallel, they've got the same gradient. So that is your first working mark. This is out of 3 marks, this part. Your second mark is for substituting them incorrectly, which I almost didn't do. So that would be minus 6 as y and 2 as x. So that would be your method mark. So you've substituted those incorrectly. And then your final one is an answer mark over here. So if we're getting L1 or y equals 4x minus 14.